Are you starting to get the idea? We're going to move on now to the main demonstration. We're going to create a set of tools that lets us find the Euler line of a triangle. If you already know what an Euler line is, great, and if you don't, you can just pick it up as we go. Alright, let's start by creating a triangle using the triangle tool from before. The first of the points on the Euler line is known as the orthocenter. That's just a fancy name for the place where the three altitudes of the triangle intersect. Alright, so let's make a tool to find the orthocenter of this triangle. The altitude, just in case you are rusty on your triangle vocabulary, is the line which you would use as the height if you're trying to calculate the area of a triangle. So we have there the three altitudes, and there's the point where they intersect. Alright, I'm sure you're getting the idea by now. So we want to select everything we drew. This time though, we don't need to select the sides of the triangle, because those weren't a part of the orthocenter. Those were just already there. And we're going to add in one more thing actually, a hide and show button. Let's go ahead and give that a better name. Alright. So you notice that the button is also selected, and it turns out that the button is even going to become part of the tool. So there is our orthocenter tool. We'll go ahead and get those lines out of the way so that they're not in the way for the next part. Alright, the second of the 3 points defining the Euler line is known as the circumcenter. And that's the name which is given to the intersection of all the perpendicular bisectors of the triangle. You might have already guessed this from the name, but the circumcenter is also the center of if we wanted to construct a circle around the triangle. Alright, so let's go ahead and make the tool for that. This tool is a little bit similar to the one we just did. It both involves perpendicular lines. They're not quite the same though. See, our point of intersection's in a different place this time. And just like we did before, we're going to put together our tool here and our hide and show button. Go ahead and give that a better name. Alright, there we go. Now the circumcenter tool is also finished. The final point on our Euler line is known as the centroid, and it's defined as the place where all the medians of the triangle intersect. Again, just in case you've forgotten, the median is when you draw a line from the vertex here to the midpoint of the opposite side. So go ahead and draw all three of those in. As you see, the point of intersection is a little bit different from the others again. We'll put in our third hide and show button. Alright, centroid. Alright, so we have all three of our tools ready. But before we do anything with those, we're going to make one more tool. So take a look at what happens when we show all of these things at the same time. It's a good thing we have those buttons. The diagram would be a mess without them. Alright, now we're going to draw the Euler line itself. We do have a lot of other lines in the way though, so let's see if we can hide some of those before we try. Alright, that was easy. And here is our Euler line for this triangle. You may have noticed that we're constructing this line using 3 points instead of 2, which can be confusing. What if all the points don't all lie along a single line? But in the case of the Euler line, it always works out if you've done the previous steps correctly. And that's part of what makes the Euler line an interesting topic to study. If you've been following along on your own, you can use this as a way to check your work. If your 3 points are all along a perfectly straight line, you've probably done everything right. As a final step, we're going to create a custom tool that draws this Euler line. Alright, so you see I've selected the Euler line and the points on it, but I also picked out the vertices of the triangle. And that's because the vertices of the triangle are the parents of this entire construction. Everything started from those vertices, and without it, the custom tool won't work. What we have here is a custom tool which is based on the work done by our 3 other custom tools. There's nothing wrong with that though. Just make sure that you keep track of your parent points as your creations get more and more complex. Alright, we've finished creating all of our custom tools. So let's go ahead and try them out a few times, just to make sure everything is working the way we think it should. So let's try applying our Euler line tool to each of these triangles. There we go, a nice Euler line for every triangle. Before we wrap up this podcast, it's important to understand how to save your custom tools so that you can use them again later. The tools we just created are only available for use in the file we're currently using, but there's a way to change that. Before we do though, think about whether you're likely to need your tools again. If you don't think you will, there's no need to do this extra step. Just in case though, here's how it works. All we need to do is save a copy of our file in a specific location. Let me show you how to do that. This step will require that you know where on your computer the Geometer Sketchpad has been installed. The tool folder is what you're looking for. And now if we look in our Custom Tools menu, the tools we wrote are available right next to the tools that were already present. If you don't see the tools that you wrote appear in the list like this, you may need to restart Sketchpad first. I did need to restart Sketchpad to get these to appear. That's all there is to it. Keep an eye out the next time you use Geometer Sketchpad. Look for shapes or constructions that you keep having to do over and over again. Maybe you could make a custom tool to save yourself a lot of time.